Why, hello. Now, I'm really sorry about the lag. I'm trying to fix it, but I can't at the moment. So what we're doing today is moving on from our units. We're looking at the volume of a prism. Now, the volume of a prism is a bit of a loaded thing because if you don't know what a prism is, well, then you've got no chance of figuring. Well, you don't really understand what you're doing when you're figuring out the volume. And prisms are different from other 3D shapes because if you were to take a cross section, in other words, a slice that's parallel to one of the front faces or the base. So if you were to cut it, it's the same the whole way through. In other words, it doesn't get smaller or it doesn't get bigger. It just stays the same. And I always use the analogy of getting a piece of salami and just slicing the salami the whole way, and so the circle stays the same the whole way through. In this case, if I had a triangular piece of salami and I was to cutting that in slices, well, unless I move the knife in a different way, if I keep it parallel, that same face is represented the whole way through, and we call them cross sections. So you see here the same base, that is exactly the same size. It's not bigger, it's not smaller, and we can take infinite slices the whole way through to get to the end. Now there's a problem here because we need then to decide, well, what is the base? And the base is the shape that the prism has the whole way through. For example, if I take slices this way for this trapezoidal prism, we've got one that's that big, but if I take one at the bottom, we see that this square is much, much, much bigger. Should I say rectangle is much bigger. What I'm trying to get at is if I take slices and I slice it this way, now it's hard for me to show on the screen, if I slice it this way across there, the slices will get bigger as I move down the shape. In this case here, if I slice at the top, I'm going to have a super thin slice up the top if I slice it that way. And as I move down, we'll see that the slices will actually get bigger and bigger. So the base of the shape then is the shape that when I do the slices, it doesn't change. It keeps on staying the same triangle the whole way through it. It doesn't actually matter where I cut it, it's still going to look the same the whole way through that shape. Whereas some people look at a square prism and they say, but square and rectangular prisms are a bit weird because I can take slices across here and these will all be the same, And it's true. It actually doesn't matter with a rectangular prism or a square-based prism which side you choose as the base, because all of them will actually work. But it does matter with the other shapes, like a trapezoidal prism, a triangular prism. In this case, you can't take slices parallel to any other side other than this one, and for it to stay the same the whole way through. So that is clearly the base. That is clearly the base. Now, I hope you understood that, because that was a bit full on. If not, you're welcome to stop and have a bit of a re-look. Otherwise, I would actually just recommend that you just have a go at some of the questions, because I think intuitively most people tend to find out which is the base or which side is the base. And so if we look, how do we actually find the volume of anything? Well, the volume of any prism is the area of the cross section, or area of the base, times by how deep it goes, or the height. Now I sometimes say area of the base times by depth, and make that D, because height is often used when you're actually calculating the area of the base sometimes. And so it sometimes gets confusing. They say, well, if that's the height, how can that be the height? Basically, it's the area of the base shape multiplied by how deep it goes. In other words, we're counting up all the slices as we go along. All right, let's give it a go. You'll see what I mean in a moment. So even before we begin, with these three shapes, you see, or you can only see two at the moment, which would be the base? Obviously, it's the shape that stays the same the whole way through. In other words, it's the cross-section that is uniform the whole way through. And so in this case, it's clearly that triangle. It's going to be the same the whole way through. The top and the bottom are exactly the same. What about this shape here? It's a bit of a hint because it's coloured in. That is the shape that is uniform the whole way through. So that is clearly the base. If we go down here, this trapezoidal prism, which one's the base? Well, it can't be any of these sides. It has to be this one because that is the shape that is uniform the whole way through. In other words, that's the shape that follows through. Let's start working it out. Well, what's the volume of this one? Well, first we need to find the area of the base, and then we need to multiply it by how deep it goes. Now, very carefully, we need to make sure that all of our units are the same. In this case, they are. So volume equals area of the base times by the depth, which, what's the area of the base? Well, it's a triangle, so it's 13 times 9 divided by 2, base times height divided by 2, times by the depth. Now, this is very, very easy to do. Now with our fancy whiz-bang calculators, we can just type it straight in. And look, I'll just show you how to do that. 13 times 9 divided by 2 times 16, boom, 936 centimetres squared. Lovely. What about B? Well, volume is the area of the base times by the depth, or the height. I like to say depth instead. But in this case, it's a little bit cheeky. We don't actually need to figure out anything here because it's given to us. Area of the base is 32 metres squared times by the depth of 8 metres. Let's type it in. 32 times 8, 256 metres cubed. Oh, I spotted a mistake that I made. That's squared. It should be cubed. Foolish man. All right. Last one we have to do is this trapezoidal prism. Now I recognize this as a trapezium because it has one set of parallel lines and then pretty much nothing else that we can work off. So volume equals area of the base times by the depth, which is, in this case, A plus B divided by 2 times perpendicular height. So 6 plus 4 divided by 2 times by 3. That's how we find the area of that. A plus B divided by 2 times perpendicular height. Times by how deep it goes, which in this case is 4 centimetres deep. So 6 plus 4 divided by 2 is 5 times 3 times 4, which is 15 times 4, which is 60 centimetres cubed. And this is what we do with volume. We have to find the area of the base and then multiply by the depth.